That's my take. We're back, and it's COMP308. We're having a discussion about school. In the winter 2017 semester, and it's week 2, part 2 of our broadcast, we just finished talking about modules, right? And again, modules it's all around this kind of stuff. We want to talk a little bit about classes. So again, there's this whole discussion this is emerging technologies, Centennial, I got to say that. We're talking about before, it was prototype-based objects we could create in JavaScript before. And that's all we could do. But now we wanted to use these easy-to-use patterns, right, that we are used to. If you do C#, if you're a C# programmer or Java programmer, you know, you understand things about instance members, static members, constructors, you know, supers, all that kind of stuff. You know, those are the same things we want to use within our classes, right? And the class structure can look something like this. We have a class vehicle. We use the constructor keyword. Instead of the name of the vehicle, normally in Java or C# you use vehicle, same name, right? But not so in ECMAScript 2015, you use constructor. And then you pass in a parameter, right? Wheels, as an example. And then what you can do is you can say something like this. This.wheels is equal to wheels. And when you say this, the context of this, you actually add a parameter, a property onto the vehicle class called wheels, where you store the wheels local variable that comes into the constructor. Okay, as soon as because it's still JavaScript, right? As soon as you assign something like this.wheels is equal to something, when you use the assignment operator, you create the property automatically. You don't have to use var. It's public, unless you otherwise say it. In JavaScript, it's all public, right? Remember, there is no public-private in ECMAScript 2015. In TypeScript allows us to feign or create syntactic sugar to give us the idea whether it's public or private. And what it does, it basically either exposes through an export keyword or not those variables, right? And we'll talk about that later. So class car extends vehicle, again, extends keyword. Here's the vehicle, the superclass, and car is a subclass of the superclass vehicle, where you can use the extends keyword to extend vehicle. And now we have a constructor that also calls the superclass the super constructor, which is this one. We pass in 4 wheels, right? And then we create a new parameter called color because we're assigning it. As soon as we assign it, we create it. We don't have to use the var or let, right? You could if you want, by the way, but in this case we're not doing that. And then we have this new color, and we passed in a color plus 4 wheels. It's a vehicle, right? It's a car. Car has 4 wheels typically, unless some countries they have 3 wheels, right? I'm thinking about Greece. Even China has 3-wheel cars, right? They have almost like a motor car. It's kind of weird, right? But for the most part, 4 wheels, right? I saw this commercial the other day, as I digress, but a 2-wheel car, literally, it was really weird. You couldn't knock it over or anything. You ever see that one? There's actually a car you drive around. It drives like a car, and you literally cannot knock this 2-wheel car over. It has some kind of gyro or something in there that will stop you from knocking it over no matter what you do, right? It's got a kickstand too, which is really weird. Anyway, and then you have a function here called toString, right? ToString method, right? And what you can do is you can do a car.toString, and the toString, this is interesting because toString is actually part of the JavaScript language. What am I doing here? Overriding, right? I'm overriding the built-in toString function for this car object, right? The car class, right? Which is, I can override my toString object to be specific, and look at how it uses the super.toString, right? I'm using the super call because, why? I'm taking my superclass, right, which is referring to the vehicle class, right? I'm applying toString to it, right? The regular toString, which is here. Here's our original toString, which also overrides the built-in toString of JavaScript, right? And then I'm adding colored, and then this color. So kind of a four-wheel colored, 4 wheels, right? So 4 wheels, colored whatever the color is, right? Colored blue. And the thing is, this is interesting. You can use the instance of keyword that's built into JavaScript to determine whether a car, lowercase c, is an instance of the car class, this class, right? And the answer, of course, would be yes, true. What about this one? Is car an instance of vehicle? Yes, right? Because it's a child of the vehicle superclass, right? So interesting ways with things that we already know and love. We can use part of it, not all of it, part of it here in ECMAScript 2015. We can extend this functionality with TypeScript, and TypeScript allows us to do more, right? Arrow functions. We talked about arrow functions last week, which is kind of like Lambda expressions, I said, right? What it really does is it takes, kind of allows us to use this and carry this, the lexical this from the scope throughout the entire call, function call, right? So an example would be something like this. I have a constant squares, right? And what's a map? Does everyone know what a map is? Map is actually built into JavaScript, right? So it's a special function. Look it up. It's a map, right? What I'm doing here is I'm saying, instead of doing an anonymous function that I'm passing in, a callback function, right? Right here, and we have callback hell in this line here, right? What I'm saying is take, the return is take n as a parameter and return, what you're returning is n times n squared. And that's what squares is. So think about what map does. I want you to think about what that does, right? So numbers.map. So I'm thinking about numbers.map. I'm mapping something, I'm adding something onto the numbers array, if you will, that allows me to square, right? Now here's another thing I can do. For numbers is a collection, right? And for each number in numbers, that's what this does. For each, again, if my number divided by 2, this is modulus, divided by 2 is exactly equal, 3 equal signs is exactly equal to, that's what it means. And what is the difference between equal, and triple equals in JavaScript? Anyone remember? Exactly equal to. What does that mean? What does exactly equal to mean? What's the difference between equal could be exactly equal to 2, right?
Compare values without any casting type.
Type. That's the thing. So both the type and the value are equal, right? So I'm looking for, it has to be number type. So I can't put equals. I can't put 0 in quotations, because normally you can put equal and 0 in quotations, and if you use equal, it'll work, right? Here, you can't put equal and 0 in quotations. It has to be a number type. So that's a number literal, plus it has to divide by, it has to be the 0, whatever the 0 is. So it has to be exactly that value. The value and the type have to match, right? That's what triple equals means. So, again, n%2 is n modulus. So divide n by 2. If the remainder is 0, exactly 0, then push, let's say we have some kind of evens collection, right? It's not shown here. But push n, the number n, whatever that number is, to the evens collection if it's an even number, if it can be divided by 2, right? So it would be even. If I can divide by 2, it means it's an even number, right? 2, 4, 6, 8, 10, 12, right? Or whatever. So what arrow functions does is it prevents us from doing an anonymous function. Like function, you have to put actually a function in there. Remember I talked about this. And then where you're returning n times n. You have to return statement. There's like a whole bunch of code you have to put in there, right? To do that. Here's another example. This is a weird example, and I want you to think about this. Here's author, right? What am I doing here when I have the curly braces in JavaScript? This is like JavaScript kind of 101, right? It's an object. Well, as soon as I use curly braces, I'm saying, hey, author is an object, right? Because I'm using curly braces. This is the literal form. This is a notation form, object notation form, right? Object notation form is one way to create an object in JavaScript, right? This is one way, right? Where I specify the properties here with a colon and its key value pairs. Here's the key, full name, which is a property, and the value, Bob Alice. That's kind of a weird, first name, 2 first names that are both different, different genders, Bob Alice, right? That's really weird. Anyways, I don't know why they chose that in the book. And then you have a books property with, an array. It's an array. It's an any array of any. We don't know what type it is. It's just an array, right? And then we have a function. Here's a function called print books, right? This is a function called print books. I don't have to put the function keyword in here. I just have to, when I use open and closing braces here, round brackets, right? Then I specify a function. Now, if this function is inside of this object, what do we call it? A method, right? Whenever we have a function inside of an object, it's a method of the object, right? And then you have this keyword, right, which specifies books, this one, That's what it means. This books means this books, right? For each book in books, in the books array, right now we have 0, right? We don't have any books. You want to console log the book itself, right? Whatever that book object is, by, and then the name of the author, which is Bob Alice. They're all from Bob Alice, right? For each book, right? For each book, return that the book is by Bob Alice, because they're all from Bob Alice anyway, because that's the full name, right? Yeah.
So 2 first names.
Like I said, it's a first name, last name. It's kind of weird. It's like, I don't know. It's like Peter Charles, right? I don't know. It's kind of weird. Right? By the way, that's, anyways. Anyway, so go back. Yeah.
So you're using this because the variable when the array of books is out of the scope of function, like this.
This, right? The reason why we're doing it is this dot book, this dot books is pointing to this collection, right? It's an array, right? And now, when instead of putting an anonymous function in here, which you couldn't do before, by the way, it was very hard to create a prop, what should we call it, its own. Well, you could do it, but when you're creating an object like this, author is the object, right? Author is pointing to this object, right? Well, it's not a class; it's just an object with object notation, right? So, object, this author object has author.fullname, and author.books, and author.printbooks, print the books, and that's what this method does. Right? Usually with a method, we have some kind of verb to indicate an action, right? Like print the books, author print books, print the books from the author, right? And here, normally, from here all the way on, I'm going to make a little bit of a space here. Forgive me when I do this. This part here is what I'm talking about, would normally be another function that's embedded within this function, right? Which is how we normally would do it. It's an anonymous, it would be anonymous, unnamed function that we just put function, and then inside the function you'd have curly braces, right? So literally you probably rewrite this thing like, if I was going to rewrite it, let me just rewrite this function for you guys right here in the PowerPoint. Why not, right? It'd be this dot books dot for each, right? And then you'd have to have some kind of book object, right? So how would you do that? You'd have function book for each book, right? Seriously. And then you'd have curly braces, right? So that's how it looked, right? And then you'd have to have some kind of return statement, right? Which returns or does something. You would have a return. Maybe we would do a console log inside there, console.log, and then all this, right? But the problem with this is, if I did a callback function, so I copied this and put it here, just showing you something. What would the value of this full name be? Undefined, because this function right here, this function, this anonymous function inside this area here, this is the problem with the old way, right? This function here, the reason why you couldn't do this is this keyword would point to this function, not this object, right? Whereas if you use an arrow function, it retains the context of this keyword to the object that it comes from. And that's the main reason why we want to use arrow functions. Yeah.
When we are using arrow functions, any function can return anything. It's not specified.
You specify this is the return. The return is anything after the arrow.
Okay. I mean,
Right. That's what it does. That's what the output is. Okay. I'm just going to kind of scrunch it up here so I won't kill the PowerPoint. So yeah. So arrow functions are really powerful, and they can be very misunderstood. And you're going to see them all over the place as lambda expressions in C#, especially when you do MVC, right? As well as all over the place with Node. I got to talk about this stuff because in the new version of Node, you will see arrow functions everywhere. And then you're going to go, I always want you to think of this. The value before the arrow, the fat arrow, this is fat arrow function is what they're called, right? The value before is the parameter that is being passed into the anonymous function. Right, that's what this is. And the value after is everything that the function is doing or being returned, depending on what you're doing. Now, you can have more than one parameter by using opening, closing round brackets. So if I go round bracket, and we're going to see that later on when I do that, it means I'm passing in more than one parameter. And if I have no parameters, what do I do? How do I pass in an empty function? Just round brackets. So round brackets by itself, round bracket, nothing in between, round bracket, arrow function, So an anonymous empty function doesn't take any parameters, but returns something else, something you want it to do, right, as a callback. Now, a lot of Node.js functions, built-in functions for Node.js, require a callback. It's required. But instead of doing an anonymous function, you're going to see it written like this with arrow functions. Okay? Let and const. Please use let all the time. That's what I want to say. No, again, let, what I want you to think about is it retains scope inside the block. And they give you some examples here in the book. And this example, right, where we use var, right, the var of I. If you were to go outside of the for loop, you would be forgiven to think that I would be undefined. But actually, it would have the last value that you put in here. And that is very bad, my friends, because that means I is retained with outside of the scope of this block. Right? However, if you use let maintains scope, right? So that means that if I look at here, I in the second example, it would be undefined. And that's what we would want, right? We wouldn't want I to escape from this for loop, because if I use the I in multiple for loops, which people do, right? Guess what's going to happen? It always has an initial value. That's very bad. And you're also, whenever I do var, I'm doing var over and over again. It's actually redeclaring the same value over and over again for that variable, which is bad, right? Let, what it does, it uses it and disposes of it. Whereas var, the memory allocation of that variable hangs out. As soon as you declare variable and with a var keyword, it's always there in the cache. That's bad. Now let me ask you this question. Would the var variable be able to escape this function scope? No. So it would stay within function, so that's where it's good. The function would, so I wouldn't be able to skip the function scope, but not so with this, right? And by the way, sometimes it would. So please use let as often as you can. How about const? Const gives me a constant, and you can't do this, right? This would throw an error, right? And this is good because sometimes we want to use a const, especially when something is not going to change. And we're going to see that a lot, right? We want to use a const because there's an opportunity for us to make mistakes. Const prevents us from making mistakes or overriding some kind of minimum or maximum value, right? Here's some other ones. Default, rest, and spread. We didn't talk about this last week at all. Default, rest, and spread. So what are they? So the default feature allows you to give a default value to a parameter that comes into a function, like this. This is available in C# and Java, but was never available before in JavaScript. Now it is. So you can give a default value. So if you don't specify y, right, like you do this, it would still give a value of 0, right? So in this case, the value of y would be 0 automatically because you've specified it here as a default, right? Nice and easy. Next, rest. The rest of is what it means. So you can say something like, well, I want my function user friends is my user plus a bunch of and everyone else in the friends collection, right? The rest of, the dot dot, right? So you can pass an array, right, as a trailing arguments. So imagine you could do user, this is the first one, you go here, and then Bob and Alice would be part of the friends array, right? And then here what you can do is you can parse the array, right? So friends.length, how many, right? Depending on how many, so user has how many friends, depending on how many, in this case 2, right? The value of the friends array, the friends collection. It's kind of weird, right? But if you see this is the rest of, this is also used in Java and also available in C#, right? If you look it up, there's very similar functionality there, right? Not so in C++. Don't even think about it, right? Yes?
I don't know.
So triple dot, these triple dots means it's the spread, or sorry, the rest feature, which it says, okay, so I'm going to have one fixed parameter, right, which is the first parameter, and I might have more than one incoming in an array. Anything else is going to go into this array. I can have 10, 20, 100 more parameters in here. And I might do that in terms of if I have many attributes that I want to add into a particular function or object or whatever, and I want them all to be stored, all the extra ones to be stored in the array, right? So all the users' friends, the friends are all stored in an array of friends, right? And then what you can do is say, well, this user, whoever's name is, or her name, has how many friends? That's what it's doing.
And the user's name is user.
In this case.
And he has 2 friends.
He has 2 friends, Bob and Alice. The first and last name we used last time.
Wait,
Bob Alice. I don't know. Yeah, it's kind of weird. They kind of said it now. It's 2 first names, right? Okay. The rest, so spread. This is neat too. So spread, what it does is it turns an array into a call argument. Okay. So example would be first friend, second friend, third friends. Notice that this third friends, right, is an array, right? And notice that I can use the spread, the rest feature, right, to say something like this. Here's my first friend, here's my second friend, and then here's my third friends, and I can say here's my user top friends. I can target the array, which is third friends, right, with this. And so what I'm doing is putting an array literal with the dot 3 dot operator that passes into this, because that's the array, these ones. And what I can do is, what it's actually going to do is going to fill in all these. Sorry, what it's going to do is going to fill Alice into first friend, Bob into second friend, and Michelle and anybody else into third friends. If I have more than this, I can have many as I want. Right? Now, I don't like this one. This to me is less useful. The first two, like this one is really useful. This one is really, really useful, right? This one, not so sure if I would use it, unless you want to have an array of arguments, right, that I pass in, and it gets, basically what it does is it parses the argument, this array, that's what it's doing. It's parsing the array into separate arguments. That's what it's doing it for, yes.
So you're saying if the array had more than 3 elements,
The other ones would be lost, right? What would you do with them? Unless the third friend's argument was a dot, dot, dot. And then it would take the last elements of the array and you don't know, you're going to get some weird, funky things going on. So be careful with this one. I understand what it does. I'm not sure what the reasons for it would be, how I would use it in a real life situation. I think differently than this. I probably wouldn't use it, but it doesn't mean that it's not there. So just, kind of take a look at default rest and spread. Those are the new ones. It's kind of like an argument list, first, second, and third, but instead of putting it in, specifying the arguments, you just put the literals. You just pass the whole literal in there. They're all the literals from the array, each element. Spread, it kind of deconstructs or decouples the array and gives different elements, a fixed parameter inside this user top friends function. Right. All right. Mean really quickly. So again, Mongo Express Angular. No, we talked about that. It uses a MVC architecture and uses a single language throughout the entire application. That's what it does, right? It also includes things like serializing and deserializing of different objects. Again, through JSON, and that's one of the things that it does, because the whole mean stack, including Angular, does a whole other thing. I talked about what the functionality of Angular is. Again, a whole front-end framework. The E is Express, which we're going to see later on. Mongo, which is the database, and Node, which is the server. Okay. And the last word for this PowerPoint slide before we stop this one is Node.js is a platform, like we said, which means its features and APIs are kept to a minimum. That's what it means. But it also allows you to plug in functionality, right, with using NPM. And we use keywords, or I want you to think about using NPM with different verbs. Install, NPM install. I'm going to install something. NPM update, NPM remove, NPM search, NPM, and there's a bunch of other ones, right? It uses keywords, and it's all on the command line. Questions around this one? Okay, I'm going to go into the next one for a second. I know there's a lot of theory today. I got to get the theory done. If I don't get this stuff done, I'm going to start presenting stuff, and you're going to go, hold on, Tom, how does this work? What are you talking about? How did it? Here it is. And it's documented for you nicely so that you can always go back and take a look at the PowerPoints if you really want to. Okay, this is a bigger one, 59 slides. I may not be able to finish it all today. I'm going to pause at some point because I have to get to actually code with you guys a little bit too. I'd like to try and do that. But I need to talk about this too. All right. We're going to talk about closures, what that is today in JavaScript as well. And I'm going to continue the whole thing. And the reason why I'm bringing both of these PowerPoints together, normally Professor Ilya would bring this second PowerPoint next week, right? But I want to introduce Express next week. I want to get right to Express because we have a lot to learn. And if we don't get to Express week 3, what's going to happen is you guys are going to be, it's going to take too long for you to do assignment number 1, right? That's why I'm giving it to you now. We're going to talk about common.js modules again and how we connect modules in Node.js, which is slightly different with the modules in ECMAScript 2015, and as well as the Connect web framework, right? and connects whole middleware pattern. And how that works? Middleware meaning the routing piece. All right, let me just bring this down a little bit more because I've based it off of different stuff. So again, this Ryan Dahl guy, he created Node.js, just as a reminder, right? And the whole idea of Ajax, right, was included. And how does this work? This two-way communication, right? He wanted to kind of take advantage of JavaScript's event-based system, right? Event-based system. So again, the idea that he wanted to use JavaScript's non-blocking sockets, which are kind of similar to, as opposed to something like, different threads. And this one here, this PowerPoint talks about how JavaScript or Node.js really works, right? Let's skip down here a little bit. We talked about this. Oh, this talks about iOS and Node.js, io.js and Node.js, how originally they were one company that started by Joint. They were the kind of, Joint was the company that owns Node.js and all that kind of stuff. They split off. There's a bit of an argument between the founders, and they brought together something called io.js. And if you notice, remember I talked about last week about how Node started off at 0.12, and then somehow it went to like Node.4 or 4. Something else in a year. And the reason why, because those groups came back together, right? We talked about that last week. Don't want to say anything more there. ECMAScript 6 support. Well, we just talked about ECMAScript 6, and Node. The latest versions of Node all have that. There are some features that are being shipped with Node, and there's other ones that are being staged to be added to Node. If you wanted to use some kind of feature, an ECMAScript feature that's not included in the latest version of Node, you can use a flag, --es staging with the feature that you want, or the ---- harmony flag with the feature, whatever feature you want to include in Node, and it would include it as part of the basic library. It would understand it, right? Again, I don't recommend staged for beginners or anything in progress. All right, that means it has been included, but you're including it as some kind of additional feature. I'm not going to upgrade to Java now, no. All right, so event-driven programming. Remember, whenever we talk about events in JavaScript, if I click a button in JavaScript, I'm actually emitting a message, an event, right? I'm actually, JavaScript isn't listening unless you create a listener. I want you to think of it that way, right? So I need to create a listener for the button. If I make a button in JavaScript, I need to create a listener. I'm listening for the button press. And then I need to have a handler, something to handle the event, a callback function to handle the event. Callback function. That means an anonymous function a lot of times, right? So now you're going to see, now you're going to see, let's close this off. Facebook, Joe sent an attachment. Thanks, Joe. Whatever the attachment is. But what you're going to see is this event-driven architecture is what Node.js uses. So all of the, instead of having, example, different threads, I have these different sockets, right, that I'm using for each of the events that are occurring. So if I request something from the server, that triggers an event. And I have a handler, the routing feature, that responds to that event. And I can have a handler respond to multiple events, right? So example, I have thousands of users, but I only have one function. And that one function, which is the routing, responds to that event. If everyone goes to a website, it responds to the event. It doesn't create additional threads. It just queues up that event for triggering, right? And actually, this seems to be a lot more, well, first of all, it allows us to do asynchronous code, right, without non-blocking. So I don't have to wait. I don't have to be on. There's no call waiting. I want you to always think about blocking code as call waiting. You have a message coming in, and I can't answer that call until I'm done my call, right? So I'm talking with Aaron right now, and Seth calls me. Too bad, Seth's going to wait. That's blocking code, right? Whereas, imagine asynchronous calling. Somehow I make a clone of myself. Multi-threading is when I make a clone of myself, right? So now I've cloned my entire process, and now I'm answering Seth's call. But I have a whole clone. And when Seth goes away, guess what? The clone hangs out. I don't know what he's going to do, right? He's going to mess with my stuff, right? But the clone is going to hang out, and it's going to add load, right? Whereas the way it works is this: with non-blocking, Aaron calls me, I answer Aaron's call, right? And then when Seth calls me, I have another phone, right? And imagine someone else calls me, I have another arm that has another phone, right? And I keep doing that over and over again, responding to all these events and in queue as many times as I can until I run out of arms, right? I know it's a weird, kind of analogy, but that's how I like to think about it. Is like call waiting is really like, some kind of event. Here's an example of how the button idea was working before. So the button, I have, now this is, forgive me, this is from the book example. I would never embed script, JavaScript in my code, right? But this is an example of how, you can actually, run this code if you really wanted to. So I have a name, an input with a type of text. So what's that? That's some kind of text field, right? And then I have with an ID of name input, right? That's the ID. And then I have an input of type button, that is a button, with an ID of show name button, and a value of show name. So it actually says show name. The button says show name, right? Now I have my script. How do I hook into my button? I need to use document get element by ID or some other function that searches for the ID called show name, and it creates a reference that sits inside of this show name button. It actually is a pointer to the HTML object, the element here. It's actually a pointer. So this show name button in script is actually a pointer to this code. Think about it. You could use it almost as the button. It's not the button, but it's a pointer to the button, right? And then what I can do is with a built-in JavaScript function, I can add an event listener. If I don't add the event listener, I can click that button all the time, 1,000 times, and it's not going to answer, right? It's not listening. JavaScript doesn't even have a phone next to its ear. The phone is disconnected. There is no phone, right? As soon as I add an event listener, right, I add the ability for me to answer the phone, all right? Otherwise, the message is going to just ring busy. It's never going to, you're never going to get me, all right? If I don't have an event listener, you can keep calling, and I'm not listening, right? But with, the idea of an event listener, right, once I establish or bind, I want you to think of the words I'm using. I'm going to bind an event listener to the show name button object, right? Now it's bound. I've registered this event, this listener. Now, what kind of event am I listening for? The click event. That's the first parameter of an event listener, right? And the second parameter is a callback function. Uh-oh. Now this is the way we would write this. I'm just going to zoom in here so you can see it. This is the way we would write it now in ECMAScript 6 or 2015, right? Instead of using an anonymous function, right? Because normally it would be written like this, right? Who cares about the event, right? We just write it like this, actually. We wouldn't even care about the event. We'd just be like this, right? Now here's the problem, right? If I did something like this, document get element by ID name input.value, right? What the hell? I mean, what it would really do is go like this. It would say, look for name input, this one, and, change the value, alert it, whatever the value is of name input, right? I want to, I'm going to somehow alert the value of it. But if there's no value, right, there's no value of name input. Right now, the value is nothing. What would it return? Nothing. Even with the anonymous function, still not going to be returning anything. I'm not setting the value here. I'm just printing the value, which is nothing right now. But it's not defined. Let me undo that. So this arrow function takes the place of the function keyword, and it retains scope. It retains this context within this script, right now, because it's not an enclosure of any kind, right? So the idea of this event listener, and the callback function here being the handler, two parts in one line, right? You could also specify a named function here, like for example, show name button click. That could be the name of a callback function or a name function if you want. That's separate, that you'd write down here somewhere, right? But normally it's written like this because, and we use anonymous functions. Why? Because if I name a function, it actually takes more memory than an unnamed function. Anonymous function resolves as soon as it's done. It delivers what I needed, and then its memory is released, right? Whereas a named function retains the memory allocation, right? So that means it's actually heavier from a memory perspective, right? However, sometimes it's cleaner to look at, right? When you look at it, you're like, okay, this anonymous function crap, I don't like it. I want to make it into some kind of named function. Yes, and you'd be forgiven to think that that's nicer and better and faster, but actually it's not, right? That's why we use anonymous functions a lot. They're actually faster to use and less memory than when we actually allocate a named function. If it's something that's going to repeat that you have to call over and over again, That's when we use a name function. We need to use it over and over again. This, obviously, you can call this function again, right? Or if it's something I'm going to share. For example, if I had a shared event handler that I want to use for a bunch of buttons, 5 buttons are going to use the same event, yes, then you would make a name function. It makes sense because that's going to be cheaper than creating and destroying a bunch of anonymous functions. And then let's talk about some other stuff. So event-driven programming is the stuff that they took. They took this idea of an event listener, right, with a name and event and an anonymous function that was, that's used as a callback for the emitted event. They took this idea, right, and they wanted to include it in this single-threaded, event loop, right, that we use. So what happens is in JavaScript, there's something called an event loop, and the event loop is always triggering. It's always firing, almost like a built-in game loop. If you're someone who's a gamer, right, it's always triggering. And this single-threaded loop, this idea, what happens is when I have an event, it goes into something called the event queue, right? So if you and I trigger the same function, let's say, for example, Omid and I, right? We press the button at the same time. Well, maybe it looks like the same time for both of us, but somebody is going to be first, right? Because that event handler is got to resolve one of our functions. So guess what? If Omid goes first, and then it's me, I'm going to go onto the event queue. I'm going to wait a little bit. It's going to be milliseconds, most likely, right? But we're using the same event. And that's what's happening. We create something called a new event queue or an event thread. It's not really a thread. It's just a little thing that's happening, right? And they're going to execute in queue order. Okay? So if I go first, then Aaron, and then Omid, and then Erlina, and I'm losing this row against Seth, as an example, then that's the order that we're going to execute it. It's going to be almost exactly the same time because JavaScript is pretty fast. And from a model perspective, it looks something like this. You have your event emitters, right? So-called listeners, right? We add event listeners here. You have your event queue, and then we take advantage of the event loop, right? And what happens is it gets handled by event handlers, anonymous functions a lot of times, right? And this idea is the idea that Node.js works from. So how does this work in the real world? I listen for, I'm listening for a path, index.html, to come in, right? When I hear that, my event handler, the route for my index.html, what serves up my page, it responds. So listener, handler. That's the way the way that that it works. And it appears to be asynchronous, right? So here's what happens. If it goes to the same handler, then it has to wait. But what if I have 10 users and they're all accessing different aspects of my page? No problem, right? Why? Because my event loop is going to be always firing, but my event handlers are going to be separate. There's going to be a separate event handler that's going to handle you and me and everybody else, depending on how many routes I have, right? Which is pretty cool. Now, you might say this is inefficient. And what happens is multi-threading applications, when I skip down here a little bit more, right? And they talked about how PHP is an example of blocking code, right? PHP example sets up this MySQL query, right? And it does a select statement from all users. So I'm returning a list of all objects from the users table, right? And then I'm going to output this. Well, guess what? I can't do this until this resolves this whole connection, which means blocking. I'm waiting, right? Remember the whole waiting example. I'm call waiting until this is done. Then I can't do this, right? And I create more threads so I can do that, right? And if you look at some examples of servers that exist, right? Here's Apache, the green, right? And notice the more users and concurrent connections, the less performant Apache is, right? Nginx, right? That's what this is called, Nginx. That's how you pronounce it. It's a node server, right? Node-based. Look at this. The performance stays pretty flat, right? Which means that's good from a concurrent perspective, concurrent user's perspective. It kind of flattens out and can maintain. It has less performance issues with thousands of users compared to Apache, which keeps on going down further and further. That means I can overload an Apache server way before I can do a classic Nginx server, right? And Nginx would be the engine of choice if you're setting up a node server. Okay, these days. Here's the other one that I like, memory allocation, right? So here's Apache, blue. This is the blue memory allocation. The memory keeps going up because you keep on creating new threads, right? Over and over and over again. What's going to happen to the Apache server? It's going to crash eventually, right? Here's Nginx. Same amount of memory because it uses a single thread. So the memory never increases, right? And that's why this architecture we're talking about, this and this, is why there's the demise of PHP and Apache and that whole stack. It's coming. It can't live anymore. We have more and more people living on this earth. There's more and more people using the same websites over and over again, right? And it can't survive with this kind of architecture, right? That's why, right? Now there's other solutions that make Apache better, and they've learned, the latest versions of Apache and PHP improve this line a lot. I'll tell you right now, right? But what's going to eventually happen is with this kind of connection. I mean, look at the memory allocation here is low, right? Look, we're talking about it's going to eventually happen, but look, memory is like in megs, right? It's not gigs, right? This is like 3,000, 3,500 connections, right? Okay, but what if you have millions of connections? Like example, some viral video, right? That could do something, right? Whereas Node, we're good, right?
Use PHP with Nginx.
Well, yes, you could. PHP with Nginx instead of Apache. Yeah, that would be the solution, right? And so that's what they've done. They've done kind of some kind of hybrid, and to make Apache, PHP live longer, right? Because PHP on the back end is grandfathered, right? And you're running, how many WordPress sites are out there? Millions, right? So like literally, WordPress is probably the #1 application that PHP enables, right? Why? It's quick and dirty. It kind of you can kind of whip out a PHP site in 5 minutes, right? With full functionality, some kind of dashboard on the back end, authentication built in. It scaffolds out an application very quick, and all you have to do is just theme it, change some of the links, and away you go. You have somebody's application ready to go. Might be slow, right? And eventually it'll slow down, because the biggest problem with PHP is, and on the back end, especially with WordPress sites, they slow down a lot until they're unusable. And there's issues around that. Closures in JavaScript. What are these closures we're talking about? Here's a closure. So again, functions that refer to variables from their parent function, right? Closures. So here's a function within a function. Oh man, we're getting into function hell is what this is called, right? Almost like callback hell, right? These two things are named functions. They got a parent function, it's called parent, and the child function called child, right? And I want to access the message variable that's defined in the parent. Can I do it? Yes, right? Can I access something that's in the child from the parent? No. Nope. It's a closure, right? This closes up anything that's inside the scope. Parent can't access the child unless I return it from the child, right? Whereas the child has access to everything in the parent, right? However, outside of this function, do I have access to the child? No, unless I return it. So return it out of the child. So closures is something that we're going to see a lot in JavaScript. What's the main closure that I always use? You guys are familiar. What's the main closure that I would use in JavaScript nowadays? There's a main closure I always use all the time. It's actually, there's a name for it, right? An IFI, right? Immediately invoke function expression, which actually is a closure that closes everything up in JavaScript when I make stuff. And I'll show you that functionality later on. So here I'm calling the parent function right here. This parent function gets called. It declares this message as a constant, hello world, right? And now it also declares the function. And then down here, the child is called. So this alert message pops up. And I do that all by calling the parent, right? Because the child call, the call to the child function happens within the parent function. So the child actually calls itself, if you think about it. All right, and here we can continue with this idea, right? Here's a simple example where it says, you can see how the child function has access to a constant defining the parent, but here's another one, right? Let's see what this one does for us, right? So we have our child's message, hello world. Oh, now we're returning the child. Remember I told you about returning the child, right? Well, guess what? If I make a child function, child fn, right, and I make it equal to the parent, if I make it equal to the parent, if I use the assignment operator, what am I doing here? I'm actually creating a reference to the calling of the parent class, right? That's what I'm doing. And when I call the parent class, because it's got the return statement, guess what? It's actually the child that I'm returning. It has nothing to do with this. It has to do with just this, right? So this is what I'm returning because I'm calling the parent, right? What I get back from it, because this returns a child, that means that the child constant is going to be equivalent, is a reference to this child function. So when I call the child function, I'm actually bypassing calling the parent and calling the child directly. Make sense? It's confusing, but we see closures in JavaScript all the time, especially in Node.js. The what? It would return? It would, because message exists inside the parent. It has access to the parent, so it would call it, but I'm calling it directly, right? It wouldn't return anything though. If I assigned it, what would it return? 0, be undefined. Because I don't have the return statement, and if I do this, right, this assignment, what's this assignment? What's it returning? The parent. If I did this, that's different, right? What's this doing? If I do this, this isn't executing. This is not executing. Executing only happens when you use the open and close brackets, right? What does this mean? Guys, how about Aaron? What do you think? What does this do instead? I changed it. What does this do? Assigning, right? This assigns the parent. So what's happening is this, the parent function, and now is this child function outside of the parent, is the parent. So when I call the parent, because let's say there's no child. Let's say there's no child function. Okay, I'm just going to comment this out as an example, right? So what happens? Nothing, right? Because the child function is never called, right? That's what this does. But if I do this, right, that's different than the other one. This, it executes the parent and then returns whatever's in the return statement. In this case, the child. It actually returns a reference to. I'm not calling the child here. Remember, just like I did this when I remove these, I remove those from the child. I'm actually creating a reference, a pointer to the function, right? And that pointer to the function is in memory. So that pointer goes and sits inside the child function. And then when I use the brackets here, it's actually doing this. It's executing this directly. Now, if you don't understand that, I know it's funky. And for some of you, it's like hard to understand what all that does, right? But that's part of it's kind of the heart of what closures are all about. And this is a key, the return. Remember I talked about it? Unless you return something out of the parent, it's locked inside. Okay? And it explains it here in the code. I don't have time to talk about it. It's just called the closure pattern. All right, common JS modules. And we talked about modules in ECMAScript 2015, right? But the idea of isolating modules is different. It's a different syntax than the ECMAScript 6 syntax. We use the require keyword and the call, right? So a require call. And the require call, what it does is it includes a reference to the module inside the place where you call it in the code. And I'll show you an example of that. And then we use exports, not export, exports, right? Which exports pieces of the code that you want, right? And we talked about what a module is. Let's take a look at some common examples. Here's a great example of that. So const message hello, exports.says hello or say hello is my function, right? So when I do this, right? And let's say, for example, this is in a hello.js module, right? So I'm exporting this idea, right? So what am I exporting? I'm not exporting the constant. Message is not available outside of the module because I'm not exporting it. Only my hello world, my says hello function. And by the way, see this? This is another way of declaring a function for those people who forgot, right? What is this actually doing? Is this really, this says hello, is this the function? What is that? It's a variable that points out. I like to think about it as an alias, right? It's almost like a pointer. So this is an anonymous function. That's what this is called because it's not a named function here, right? I'm assigning the anonymous function itself, the whole function, hello or say hello variable. And then I'm saying this method exports this variable. right? So now really what I'm doing is exporting the whole function. Syntax. It's just syntax. When you see it, don't be confused by it. That's why I'm showing it to you. All right. Here's an example. Const. So after I've done this, const message hello, and here's I'm exporting say hello, right? I'm creating a new hello const again, which I'm using the require keyword. I'm not using import anymore. I'm using the require keyword in Node.js, right? So in my server.js, I'm using the require keyword, and I use the dot slash to say that the hello JavaScript file is in the same root, right? The same directory, same folder as my hello.js. Hello.js and server.js are in the same folder, and the dot slash says access the hello.js, the hello.js file, and require import anything that's been exported, that's been flagged for export into this hello object. Please don't think of this as a variable anymore. Why? Because this can include a lot of stuff. Like, for example, think about this as a pure object. I don't have to use the new keyword here. Once I use require, anything that comes in from the module into this placeholder, if you will, variable, it's actually an object, which means if I have 20 things that I export, they all go into the hello, variable, right? And then I can do something like hello, local hello, say hello, hello.say hello, which is kind of weird, right? So you're going to see this a lot. It's the idea that each of the modules are self-contained. They're equivalent to being a closure, right? You can't get out of them, but they have access to everything inside of them, right? It was required. We had to do this because, remember, we don't have an index.html. There is no index.html when it comes to Node.js. Index.html is only a view, right? We don't have a view. All we have is the backend. JavaScript on the backend. It has to run inside of this manifest called server.js. And server.js, like I said, links everything together. So you needed another structure, and that's why we use require, right? All right. I know I'm going at length with this, but you need to understand this, because once I start showing it to you, you're going to go, oh, okay, I get it now. And even then, maybe you won't. Here's another example. I can also use the module.exports pointer. That's what this thing is, right? And when I do this, what it does is it says that the whole module, right, I'm creating a module now instead of just my exports. This whole function now is being returned. This function, a reference to this whole function, right? And what happens is when I do this, I create a pointer to the hello file, hello.js. Notice I don't need the .js at the end, right? And when I execute it like this, it executes this function, very similar to what we did last time. It's just written a little differently. So you can see it like this as well. So CommonJS is what it's called, right? CommonJS. And we use that for external modules that we write, as well as third-party modules that are written for us and that we can download and install using NPM. And where do those modules sit? They actually sit somewhere physically in our project under a folder called node_modules, node modules. You'll see that inside of our folder structure when I go into the code part, right? Yes. Yeah, let's take a look at the difference. So, good question. So here's the first example, right? Exports.saysHello function, right? And here's the second example. Module exports function. Is there a name for the function? Here, there's a name for the function, right? Here's the function name, says hello, right? You're exporting the name of the function. So when I do an import, right here, require, I can do it, say hello. That method is now linked to this object hello, module object dot method, right? Remember, here's the method. Not so in this example. In this example, and you're very good to see that, right? In this example, we have an anonymous function that we're creating a reference to this. So now we're just calling it directly. There is no object. I want you to think about this hello in this example as the function, because it's a pointer to the function itself directly. That's a totally different thing. And I want you to remember that, because one creates an object that has a method of the same name, right? And the other one is a pointer to the object, right? It is the object itself. Core modules, and I want to go over this really quickly. Core modules, there's a bunch of stuff that's been compiled with Node, with the whole Node architecture. It's included. You don't have to go and get a module from somewhere else. And there's some really cool core modules, and I want to go to the Node.js documentation for this in a second. One of them is HTTP. That's the core module that's built in. And FS would be the file system. File system and HTTP and HTTPS, all that's built in. You use the require method still, so you can activate those built-in modules, right? But they're already included in Node. You don't have to download anything, right? And here's some examples of this. So constant, and this is bad, but you could also call this file system. File system is required FS. Remember a require FS? Now the file system, this object is an object now in this case, right? It has read file, which is part of the built-in Node.js module, FS. I didn't create this. It's not. You're not making one. You're using it. And if you want to know, if you want to look at Node.js, I recommend you look at the Node.js site for a second. This is important, right? If you ever want to use any built-in or core modules, right? Take a look at the docs for Node.js, right? And if you look at the documentation, it talks about different API documentations for all of them, right? For 5.x and beyond. Here's the latest one, the 7.4 API, right? And if I go through here and I look at all the things that are built in, you can see Crypto Console. Here's all the core modules. HTTP is an example. And a lot of times what they'll do is they'll give you the class, right? And they've broken it out in very TypeScript-like, by the way, I'll tell you right now, right? And you can get examples of this kind of stuff. For example, if I want to take a look at this HTTP agent class, it'll go into detail about how to make that work. Here's HTTP GET. That's actually built into Node.js, and they give you, look, fat arrow function examples, right? So if you don't understand this methodology, that's why we're talking about fat arrow functions. This is right on the documentation. You want to understand what this means. So what this is doing is I need to pass into the HTTP GET, I need to pass in a bunch of options, right? And then I need a callback function that takes the response object, right, and returns whatever you want to do, right? That's what this does. And then we have on. What's on? It's the new way of doing event handling. Instead of add event listener, I'm creating an event listener, or it's like a promise, right? So after I get everything and I get my response and I do stuff, right? When I get a new socket, I'm going to pass this, an anonymous function. Here's the callback where I emit agent remove, whatever that does, right? So this is an example of how I can, respond to something. Here's another example. Alternatively, HTTP GET. Here is an object, right, for all of my options. Remember, options was the thing I needed. I'm passing in an object for this. I could also pass it in as a class, an object that I create with ECMAScript 2016, right? Or an object object literal that I make with object notation that you saw earlier, right? I'm passing it in. These are the attributes of my object: host name, port, and path, and so on, right? And then in my response callback, I do stuff without any kind of other event. So again, this is the way it's all been written. And the latest version, I'm looking at the latest version of Node.js. These are all the built-in the core functions, as well as other information that's built in here. But it's actually quite interesting what you can do, right? Without doing anything extra. For example, path, that's a core module, right? You're going to see path module. What does it do? Right? Well, if you look at it, it does things like I can get the directory name. So path, direct, these are all part of the path module, the core path module. If you scroll down here, it gives you some really good examples of how this works. Like path base name is equal to this, if you really wanted to do that. By the way, I don't recommend this. It's absolute pathing, right? But if you really wanted to, you can do that. And then it tells you the path and the base name. This is one of the methods that are built into path, the path core module, right? Notice that the path itself is a type string. It tells you everything, like what path it does, what it returns. And guys and girls, I really want you to be familiar with this API documentation on Node.js, because if you ever want to do something, you think about doing something like, I want to get the directory of my folder, right? Okay. Geez, is there a directory here? No, but there's a path. And that means I can get the directory name. Here's the directory name. And this is how you do it, right? Path directory name is this. I can set it, right? I can also do other things. And if you look through here in terms of getting the directory name, right? So this returns this as a directory name, right? It's interesting, right? It kind of, kind of returns. I can set or get this. There's both a getter and the setter for this, right? So keep looking through here if you're interested, because this is a lot of interesting stuff. Console is another one, right? Console.log. Here's console.log. It explains what the console is actually built into Node.js. It's not the console log we're used to, right? Console log actually outputs to the terminal, like we said before, right? And it tells you examples of how it works. Please look at these examples. If you have a weird error, all the core modules are here, right? So again, I'm gonna save this up. So I'm gonna go back to Node.js, and I'm gonna go to docs. I'm gonna kind of take this docs and put it into our Slack. So again, it's Node.js or module, docs. That in there. That's what it is. So you can get all those documentation, and I recommend you look at them, right? I mean, it's something that we're going to all have to look at eventually. All right, so no module. So this is FS is obviously, it gives you read file. And then as an example here, this is absolute, or this positioning here. I'm reading a file I'm reading the host file. This is obviously on the Mac, right? Or some kind of Linux system, because there is no etc host file on Windows. It's a different path, right? Could I put in a path here? Yeah, I could format a path. I could use the path core module. So I could go const path is equal to require path. And now I have path functionality where I can put in the directory name of the module right here to help me format a path for the directory, right? And then look what I'm getting. I'm getting a callback. Here's a callback, right? Here's the callback function, which takes two variables, two parameters, an error parameter and a data parameter. The error parameter, if there's an error, it returns what the error is on the console. Otherwise, it takes the data, returns the data to the console. Notice that I don't have an if statement. Why? Why don't I have an if? Why don't I have an else statement here? I have the return, right? That means that if this actually triggers, this return triggers, it's an error, it'll never get here, right? So therefore, I don't need an else. Actually, this is very C-like. If you look at C++, they do a lot of this. Could I put an else? Yes. Do I need an else? No, right? Doesn't make sense. So this reads, you can use read file to read a host file and then take that data and output the host file to the console, the whole host file, right? Or store it somewhere else, right? Logging is great like this. You can log server logs. You can use this for server logging, read file or write file, right? You can see that. Other ones. So there's the third-party modules. If I was to download third-party modules, how do I do it? I use npm. And Express is a great example of a third-party module that we're going to explore today, right? A little bit. We shouldn't. We're supposed to explore it next week, but I'm going to do it today, right? Because, like I said, we need to get you jump-started on Express as fast as possible, right? I'm going to take a short break in a second. Just bear with me while I do this. I get through this PowerPoint stuff, because without this, again, knowledge would be, knowledge is power. All right, here's an example of that. So I've got an Express. I'm getting an Express application, right? A reference to the Express app. Okay, here it is, right here. I'm just going to zoom in there. This is an example of what you might see when I create a reference to Express. I'm including Express here. Now, Express is a whole framework, right? A bunch of modules that already includes. I want you to think of it Express as like a whole application that I'm loading into Express itself, a whole set of methods. And now what I'm doing is when I'm using a new variable, look how I'm referring to Express here. I've kind of referred to it twice. Why? Because I'm executing Express. When I execute the Express module, the return, what it returns is being stored in app, right? What is being returned by Express? Unless you actually look at the Express module. For people who don't know what I'm talking about, please see Express, right? If I go to Express.js, right? And if I go to expressjs.com, the Express.js module is really here, and it talks about everything from routing to middleware to a bunch of other stuff here. There's Express 5, which is the latest version of Express. It used to be Express 3. So some old, and this wasn't that long ago. Last year, it was like we're moving from Express 3 to 4, right? Now we're moving from Express 4 to 5. And Express 5 has additional things that are in there, right? And there's a whole guide. If I click on guide, you can see that how do I create an Express application? And this is exactly what we have from the book, right? We require Express. We basically execute the Express framework and store the classes and the returns in here. And then I can do something like this. App get. When I do app get, I do a get request. I respond to a get request. I want you to hear me now. I respond to any get request that goes to the root of my website, and then I have a callback function. Whenever someone goes to the root of my website, I return hello world. That's what it does. That's how you do that. That's just basic routing right there. And I can do more app gets for every path that's in my web application. And they talk about root methods here as an example with posts and gets. What's the difference in posts and gets? Post, what it does, it processes the data, right? Get returns the web page. That's what it does, right? Two different things. And so this is an example of Express, right? So we're going to be dealing with Express next week, more and more in detail. But this is an example, like from the book, that allows us to install Express as a third-party module, require it like we do anything local, whether it's a core module in Node.js or our own. You can make our own here too, right? And then in the next line, we execute Express and store the instance of the whole of the Express object inside the app variable. So app is actually an instance, without using the new keyword, right, of the Express class or module, if you will, right? So I'm instancing here, right? Once I do this, I'm executing the constructor, right, from Express. And it's returning a reference to the an object of type of Express. That's what I'm doing here. Now, for those people who don't understand, it's okay. And where is it being stored in? All the external modules get stored in Node modules, like I said. One more couple things here. All right. So here's const hello. I can create a path. I can call it something. I can make a folder called modules inside my application. And here's relative path. This is relative path, right? Where I say, hey, go to the modules. Anyone, if you guys go to the same, I can have the same application. Hello then is going to this hello module that's inside the modules folder that I created, right? This is pathing we're talking about here. Here's absolute pathing. This is bad. I don't want to do this too much because maybe this won't work for you, depending on what system you're on. I'd rather prefer this method, okay, where I use dot and dot dot and so on to get relative path. And here's an example again. So hello requires this hello module, and the idea that this module gets loaded into the hello variable, this constant, if you will, as a reference to the whole module, right? If something is being executed here, then hello is actually an object. Okay. We talked about third-party modules, right? We talked about how we developed Node applications. And one of the first kind of most useful modules that were kind of created was something called Connect, right? And remember, when we create modules, third-party modules for Node, they're lean, which means that all of them, all third-party modules in Node are as lean and simple as possible. And then what we can do is we can activate features on top of them or add additional modules to extend their functionality, my Node application, right? So my Node application is made up of a number of modules that I include through the require statement at the top of my server.js. That's what I'm going to do. So I'm going to say require, require, require. I'm going to keep doing requires all the way down until I've kind of required all the main modules, right? Once I've done that, once I've required all those main modules, then I have my server application running. And in the next pages, I'm not going to go over this. I want you to go over some of this to understand Connect a little bit. But in the next pages, it talks about how Connect has a certain structure. Here's an idea of what we did last week. We kind of created this HTTP we kind of required the HTTP module, right, which is a core module in Node.js. This is review. We use the create server method that's built into the HTTP object. This is now an object because we've required it, remember? And so this HTTP constant is a pointer to the whole require module, right? This HTTP module, right? And now I can go HTTP create server, because create server is a method of the HTTP object, right? And it requires, notice that this is written wrong. What's wrong here? You don't need this, right? Right? That's wrong. That's probably from the book, by the way, right? You don't need this. You just need this. So if I save it, all right, this is what this is the callback function, right? And so it requires a callback function that returns, this. It's going to write the head of your, in writing head of the HTML is required, right? That's what this does. And then at the end, it returns hello world. So it's going to be a plain text document that has no HTML, just this hello world object. And then you're going to chain this listen method, which kicks off the listener on port 3000. That's what it does in the local host 127.0.0.1 as a default, right? Again, more information about HTTP, please see the Node.js API documentation, okay? When we use a console log, console is a built-in method that I don't have to, our core module that I don't have to include. It's included in the core, right? And I output server running at localhost 3000 to the terminal or command prompt. Okay? Nothing new here. It's just telling me, it's just saying everything I told you. Now, from page 46 in your notes, all the way down to the last pages, which is page 59. So we're talking about another 13 pages I'm not going to go over, right? After the break, I want you guys to take a look at it. I want you to create, this is where we kind of start creating. I want you to create a little connect, and it talks about connect here, all right? So very, very clear. And this is right from the book. I want you to create a little connect server, right? It looks like something like this. You're going to do this by yourself. I want you to go up on Visual Studio Code, create a little connect server, right? And listen on port 3000, right? That's what you're doing here. And this piece right here on page 51, it just creates a server. Is it returning anything? If I go to localhost, or if I go to if I search for the main site there, is it returning anything if I go to localhost 3000? No, there's no routing involved here, right? So if you skip down here, and if you go down here, what about now, right? So here's I'm connecting, nothing. 52 talks about this, and then it talks about request, response, and next. Request, response, and next, these three properties here, right, are always required when we do a get, right? Any kind of get request, okay? So it keeps talking about how we can use the app use method, right, as part of our routing, okay? So there's some hints about how to get this going, okay? So here's, if you scroll down, it gives you the complete way of doing this thing. There's a logger. We're going to talk about that later on, right? Here, I'm requiring connect. I'm activating connect, right? I'm making my app an instance of the connect class really quickly, right? This is all the stuff we just talked about. I want you to practice it, all right, for a bit. And then after that, we have a couple of functions. One is the logger function. One is the hello world function, right here. And notice we also have a goodbye world function, right? And down in here in the bottom, we have app use logger, app use /hello, and app use goodbye. Okay, I want you to look up the API for connect. So if I go to the connect module, this is just a module, right? So connect.js, what it is, right? Here it is, connect.js npm module, right? There it is. And it tells you how to use it. Install connect.js. Is this the right one? No, it's not. It's connect, right? I'll tell you, because you're gonna get to the point where here it is, get connect.js, right? Here's the connect.js module. If you want to look at the GitHub link for it, where it kind of requires connect, as an example with vars inside the connect.js module. Where else? Where else can I get it? Where can I find connect.js? Is it this one? Right. So here's connect. Is that the one? Connect Tech, the Southeast Premier Web and Mobile Dev Conference. No, that's not that one, right? That ended in 2016, right? So where do I get connect? I mean, obviously, npm connect is where I want. What if I did that? Connect. So if I go npm connect, right? I'm looking at the module. I want to look at this npm module called connect. This is the module. And this gives us an example of how everything goes, and all your documentation for Connect is right here through NPM. It tells you how to get started, it tells you how to create an app, and it tells you how to use the middleware to do routing, okay? So what I want you to do is I want you to build a little Connect server that has 2 roots, right? One of them is the /, which is the root. I want you to try this out. This is not for marks. I want you to try it for trial and error to figure it out. I want you to figure out the pathing. I want you to set up the template for your Visual Studio Code. I want you to run it locally, all the stuff we did last week. All right, I want you to set that up. And then I'm going to give you a little bit of time to do that. And then when you come back, we'll do it together. All right? So that's what we're going to do on the break. For those people who are watching remotely, and I know those people who are watching remotely, please look at the Connect, NPM Connect module. I'm going to put this up on Slack for you guys to have the link. So please see, NPM Connect docs, right? And the exercise is, for those people who are watching, create a little server that responds to 2 things. The root. So I go to the server itself. I just type in localhost 3000 and I go there. I get something. And the other one is I want you to make a hello root, right? And when I go to my hello root, so if I go localhost 3000 / hello, it gives me something else. And if you want to really push yourself, do a goodbye root too. Hello, goodbye. Make a couple roots for yourself, right? And you can do that with the app use or connect.use. If you look at the module, it gives you an example. We create, when we make the app variable, by the way, would we use var? No, what would we use? Let or const is okay to use, right? And then once we do this, we want to use the app use method, right? And if you notice, there's some examples of the app use method, right? After we get started, if you keep scrolling down here to see what it does, like this, further down the page, this is an exact way of doing it. So I want you to take this, the code online, and use it to create a little server. Okay? Let's take a break, and when I come back, I'm going to check you. We're going to take about, for people who are online, we're sitting at 11:15, right? This thing ends at 12:30, right? So we can only take about half an hour, right, to do all this stuff, and then we're going to come back with a little bit more code. Okay, so half an hour, and then we'll be back.